go, just so I can get you into lunch by 11:30. We'll go to lunch at that time, even if we're not finished with the chapter. What we will do is, I want to make sure I give people time to, for those who are new to it, it may take you a little bit longer. So you can start to work on the lab during lunch. And even if I'm not finished with the lecture, we will just finish it up when you first come back and then move on to chapter 6. So let's look at the format. We'll finish chapter 5 today, and we'll also start this amazing chapter 6 today, right? Chapter 6. And tomorrow, and this happens very often, tomorrow the focus is just on these three, which is perfectly fine, right? Data pipelines, event streaming, design decisions. This last chapter is about a 15-minute chapter, which it's very short introduction to Confluent Cloud. And that completes it, but we're still in a good standing. This is typically my format when I teach this class. I try not to rush it very quickly, but I will take you guys through step by step. And just know that for everything that we cover, depending on your background, if you are new to this, don't get overwhelmed. And because it's a lot of things all coming together. As long as you get the basic concepts, you'll be fine. And if you are an old timer, know some of you have been around for a long time with programming technologies, then as long as you get these concepts, one of the things I will show you before you leave the class, remember, I will take you for a tour, the source code, the API, the KIP, and our blogs. And from those, it will just be a matter of your own expertise, like how comfortable you are and how much time you have. But there will be no mystery after that. So let's just go on now for this chapter 5. So this chapter says, after this module, you'll be able to describe Kafka schemas, how they work, and then use Confluent Schema Registry, then write messages using schema, enable Kafka client tools. Schemas are super important. And this is something I remember there was a presentation one time where the salesperson had a little drawing like this. And then he asked the audience, he said, "What's in this can? This is a can, but can you tell me what's in the can?" And then everybody laughed. But it was a really great intro to it, very high level, very simple thing. But he says, that's the whole point. Unless you have something that describes the content or the data, you have no way. So if I put you a soup, then now you know this is the can of soup. So this is like your metadata, right? Or metadata, or which is a description of what's inside, or is, you think of it as your schema. We'll get into schemas in more detail. But it's very important to have the right schema in any environment that you work in. So when I talk about introduction to schemas, before you start to talk about schema, you want to be more comfortable with the kind of data sets or data types that you work with in general. Now, most people are familiar with working with texts. So texts are okay to work with, but text has some issues and some properties, right? The pros and cons. If you're working with text, it's easy. It's supported by most programming language, and you can see all the errors when something happens. You see everything's visible to you. But if you look at the cons, which are the negatives, the data is stored inefficiently for text, right? And if you have non-text data, as you can see right there, they need to be converted to strings. There's no type check-in. It's inefficient to convert binaries. And there's no schema evolution. And when you say, what does it mean by schema evolution? Let's say if I write data today and the data has name, date of birth, and salary. And in the future, I want to change the schema, or I want to change the data format to have name, date of birth, salary, and then maybe some other information to say, look, this now has email. Well, I don't want the applications to break that would be reading this data. So I need the schema to evolve, to change. I want the new applications to read the old schema, and I want the old applications to be able to read the data that is produced using the new schema. So this is the kind of stuff they call schema evolution. If you create something that can change over time, then it will evolve. And so when you're dealing with text, it doesn't do that. And then when you're talking about data in general, you want to understand different kinds of data, right? The schema is what describes the structure of the data. And in Kafka or in most environments, that becomes kind of like the contract, right? It's sort of like your API. right? So you produce data, consumer can consume data, but you agree upon the schema, like how we are going to look at this data, right? So the consumer will always know what to expect from the producer. No surprises, like they were saying, no documentation. But when we first start working with data, we want to know, again, you want to understand the concept of structure and semi-structure and unstructured. So if you look at, if someone says, well, what is the example of structured data? Unstructured data, I should say. Think of it like a text, like just a whole bunch of lines, text, right? Like a text file. Doesn't have a subject, title, nothing, just a bunch of words. That's unstructured, example of unstructured data. But then you also have this concept of semi-structure, right? And when you say semi-structure, think of it like this, but more like an email. Let's say email, where you have a subject and you have title, field right there, subject, and then you have just the body. So this is semi-structure because you have the structure up here and you have unstructured, so it's semi-structure. So email is an example of semi-structured data type. And of course, all of you guys are familiar with this one, structured data type, like a database, right? When you create a table, you have to specify name, it's a string, you know, age is an int. You specify the types, you create a schema. An example perfectly is like a database. And so this shows you that you have some means of describing schema. So in some environment, right, you have this concept of schema on read, what they call schema on read, right? On read, or you have schema on write. So when you say schema on read, that's, for example, like in Hadoop world, right? Where you can write any kind of data files to the Hadoop cluster and you don't have to worry about the format. But when you go to read those files, you have to understand the format. And sort of like Kafka too, to some extent, but you write, but you have to understand the format when you go to read the data. Whereas a schema on write, well, we can also make Kafka behave this way too, because we can enforce the schema when you go to write the data into Kafka. And if it doesn't match the schema, we can fill it, right? But Kafka on write is like in the database world when you have a schema that you must adhere to. So does schema also indicate what kind of serialization the record uses? Well, when you use, let's just put it this way. If we use something like Avro is a general serialization, general purpose serialization framework. So when you use an Avro, you create the schema, you use JSON notation to create your schema, but it still follows, you know, the serialization occurs. And if you use protobuf as well, right, you define your schema, but then, so it's an interesting question, but it indicates what kind, yeah. So it depends on what you're using, but yeah. So you do have to, you will, depending on what you use, you will know what kind of serialization you are doing. So it's an interesting question, but you'll see this based on what we're doing. I will try to see if I can explain that a better way. I'm trying to think of a great answer, but yeah. So now this one says schema evolution. Always have a schema evolution plan in place. In other words, I create data using a schema and I call this version 1. Then I write some other data and I use a schema, I call this version 2. And over time, I can use version 3. But notice it's going from all gray squares to checkered squares, gray and white, and then to squares with yellow stars. It's just a course developer way of showing you that, look, we are changing, the business requirements changes over time, and we need to be able to adapt to the changes. So we need to be able to create a schema that can write. We don't want the applications to break, right? You have data out there on your servers. You don't want the application that you write today to break because it doesn't know how to read the data. And what if there's an application that's still running in production that was written a year ago? I don't want that application to break as well, just because I'm writing new, data that it doesn't understand. So if I create a schema and I plan to evolve this properly, I will be able to handle these changes like whether it's new or old changes, right? I will be able to handle these kinds of changes. And yeah, so let's look at this. So serialization, as you know from programming, is where a way of representing, like I said, data in memory as a series of bytes. But when you need to transfer the data across the network, or whether you're storing it on the disk, you typically want to serialize it. And you know from Java, right? Objects have attributes and properties, and go through a serialization. Then you can store or transfer the data. And then you need to deserialize it to get back your attributes and your properties. So Kafka has its own serialization classes, like the common serialization, Kafka common serialization, but there's other frameworks, and this is what we're going to talk about. So serializers and deserializers, they don't have to be standard. They're not standard across operating systems and programming languages. So what Kafka tries to do is use these serialization classes, right? But they're based on other simple types. And but we will see that we want to be able to handle complex record types, right? And we want to be able to have schemas that are complex. So we need to go beyond the simple simple types that we use, right? We want to use something more beyond those, go beyond those simple serialization classes. So this is where we come into stuff like Avro, Protobuf, and now Kafka also supports JSON as well. So all of these are supported format we'll talk about right now. And let's look at this. So we want to go beyond the simple classes. Kafka gives us a way to do it. And we will say, well, this is not so much a Kafka product, by the way. Avro is something that was created by the same guy that created Hadoop. The gentleman name is Doug Cutton. I hope I spelled it correct. But he's the creator of Hadoop. And Hadoop stores large files, right? So in the Hadoop world, you have the Hadoop distributed file system that is called HDFS. And in HDFS, it prefers large files. And when I say large files, the bigger the files, the better. So if you have a file that is 200 megabyte, Hadoop is very happy with this. If the file is 1 gigabyte, Hadoop is even happier. The bigger the file, the better for Hadoop, right? So in the Hadoop world, when Doug Cutton decided to, when he came up with this Avro was created to support, schemas in Hadoop. And this is important historical information, because think about it. What I've just said to you is that Hadoop has a Hadoop distributed file system called HDFS that prefers to store large files. The larger the files, the better. So if we have a large file and we use Avro, what Avro does as an efficient data serialization system is Avro adds the schema in the file, right? So pretend that that's the schema. Avro stores the schema in the file. And as I just mentioned, if you have a file that is this big, no problem with the schema being in the file, right? But in Kafka, our messages are pretty small, right? We have messages less than 1 megabyte. Your message could be 100 bytes. Your message could be 200 bytes. Your message could be 1K. So if this is my message size, and maybe this message is just 100 bytes, I don't want to add schema with this message that may almost double the size of the message, right? I don't want to add the schema there. So I want to prevent, right? I don't want to add the schema, although I can. And remember, Avro puts the schema with the data. So I'm building a case for you to let you know why it's going to be important when we talk about schema registry. Because think about this. If I put the schema with the data, let me give you another analogy that may make sense to you. Imagine you're traveling and you're traveling for work, and on your last day of work, you have your suitcase, right? And you now have to pick up your suitcase, and here's your suitcase. You have a choice. You can carry it around with you, or you can check it into the valet, and the valet can give you a little tag that you can put into your pocket, right? But imagine this now is like you are the Kafka rec message, and this suitcase is like your schema. If you're carrying it around with you, and imagine if every other citizen on the road is also carrying a suitcase, right? Yes, you can still go from point A to point B, but you're not going to be as efficient as if you were walking without that suitcase and just have this little sticker in your pocket, right? So putting a schema with the data is like taking your suitcase around with you in the streets, and all the other people, citizens of the street, are also carrying their suitcase around. Because so if someone comes up to you and say, in Kafka, do I need to have a schema registry? You can say, no, you don't need to have a schema registry. It's like saying, I don't need to check my suitcase in. I can take my suitcase around with me all day. Yes, you can take the schema with the message, but then now my question to you, is that really efficient? And all of you know the answer to that, right? Because I'm sure everybody has walked down the street with their suitcase at some point. You know, it's not really efficient. You still get to your destination, but it's not efficient way to travel. So keep this in mind when we talk about Avro, because we'll get to the schema registry. Just know that Avro is an Apache open source project, fast binary data format, supported by many programming languages, defines the schema. So we use JSON notation. And this page shows an example of it right here. Let me just, so on this page, see, we're using JSON notation. That's the key value pair separated by colon. So here's the name, colon, then is latitude, and then type, double. So you have name, what the name is, and then type, what the type is. And then you have it. So JSON notation is like whatever the key is, double quotes around the key, then you put a colon, then double quotes around the value, then you put a colon. So when you use JSON notation, that's it. So Avro uses this notation to build the schema. And we'll talk about the top of Avro just a second. But for now, let's go on. When you're working with Avro, right, you have these different ways to use the schema, right? So Avro supports the 3 different ways of creating records. You have generic records, the reflection records, and specific records. And the most important ones that you will be using is this specific record, where we write a schema using this JSON notation, and then we'll generate the classes from the schema that we can include in our program, right? So you write the schema, but then you will have actual class that you can use in your code. The reflection records is something that you don't see often, but you manually create it. It's like reverse engineering. You create the data and then you generate the schema from the code. I haven't actually even used that once. And then generic is another one that you may also use. You manually write the schema, then you create the generic record object from Avro, and they say use it for quickly changing or highly variable schemas. And this one specific is the one we will do in the course, which is the most common way. You actually build this class file that you can use in your code, right? And so when you're talking about Avro, remember, you can define the structure of your data. We can match whatever our data look like. We use the Avro types to build the structure so that we're telling Kafka, hey, this is what our data looks like, right? When we built this schema. And then we will build a class file from that, right? Generate the class file from that schema. So let's look at this. We want to be able to build Avro data, Avro records. Now, one thing I skipped here, on this page, if you look at this page, you'll see that this just shows you a picture example of what an Avro schema looks like, this picture right here. One of the things we'll be talking about soon is that if you look at the top, it looks pretty standard. You have a namespace, sort of like when you write a Java program and you use like the reverse DNS or reverse domain name, like this is clients.avro. It could be like a reverse of your DNS, but it's just like a namespace in Java. And then you have a type. Now this type that says record, this is just like if you ever did C programming, you know that you can create your own derived data type, right? Remember something like a struct in C programming, for example, you can do something like this struct. And I can say, for example, student record. And I say the student record. Yeah, student has you have a name, you have like this string, you have the age. Again, I switch between different formats of databases, so it doesn't matter. Yeah. But you have age, let's say int, you have date of birth, whatever type you want. But this is now, whenever I refer to student record has a name, has an age, this is my new data type called student record. So when you're using struct in C, you can create your own, you can derive your own data type. Well, you say, what does this have to do with Avro, Hussein? Because here we're using Avro, and I just told you this is like standard, like a DNS name, like you're using Java package. This one, we said this is the type. It's not a struct, but we call it the record. It's a record type. And then we are going to create we're going to define this here. We say, look, the name is not student record, but it's position value. That's the name. Okay. And this has, now here is this part of it right here. It's right here. It says, look, I have a name that's latitude, and the type is a double. Name, longitude, type is a double. And this is where I'm defining the type sort of like here. But so if you look at it, it's not that different from what you know, right? But Avro has all the simple types, just like Java. You have Boolean, int, long, float, double, just like the Java equivalent. No difference there. No need to spend time on that. Then you also have string, bytes, and null. Null is just the absence of a value. No difference on that as well, right? You guys are familiar with this, basic in all programming language. But then Avro also supports, you see, these are simple data types. So Avro also supports complex data types. And if you're going to build your own, if you want to support the complex data type, then the most important one is the record. That's like the struct in C. Notice to say user-defined field comprising one or more simple complex type. So I use this record, and I can use all of these simple types that I've seen here to build my record, or I can include others, just like in Java, enum, right? Just like a Java enum, a union, array, a map, key value pairs, but the key is always a string when you use a map, okay? Fixed, logical. And these are examples of what you can do to build the Avro type. And so what we need to do now is show you some perfect examples of, okay, let's build a schema for this, show you an example of how it works. So if we look at this example here, Avro schema, remember, just like a struct called student record, or we call this one position value, name position value. It's not student record, it's position value. And we're using a record type. That's like our struct. And we know that this is like our Java package name, you know, namespace. So you just do that. So this is sort of, okay, no big deal. Then we say fields. We have here, we say, look, we have latitude, type, double. If you put it on the same line, you just have to put a comma there, right? You don't have to put it on the same line, but if you put it on the same line, put a comma there to separate it, right? And this is perfectly okay. You could have it on the second line. It just will eat up the white space. So I don't need to have it on the same line. As long as I have that comment, I can have it on the second line. So very straightforward, right? This, we just created a position value. That's it. That has a latitude and a longitude. And latitude is double and longitude is double. That's a very easy one. Okay. And then here's another one. This one is not called student record. What is it called? It's called train arrive. This is our new thing. And of course, it's like a struct, we're using record. Here's the reverse, like I said, like a namespace. Notice they are actually using the reverse of the DNS name. Again, just a standard in programming. And then here are the fields. I said, look, I have a train ID that is an int. I have a station ID that is an int, just like in a database. When you say create table and you say, I want train ID to be this int I want station ID, but we're not doing it in the database. We're using this JSON notation, key value pair, to define it. And then now also we added something new here, doc. The document attribute is very important when you create defining your schema. Because imagine, what if I have like euros, right? What if I was working with currency? Is it euros or is it dollars? Or is it renminbi, right? What is the currency? So it's good to have a doc attribute to say, if I had something that I was dealing with currency, it would be nice to put a doc attribute to say this is in euros or this is in US dollars, right? USD, whatever. So doc attribute is very important. All it is just specify DOC in double quote. Remember, key value pair separated by colon, and then whatever you want to put the colon there. Yes, right? It's very simple. So then schema naming conventions. So by default, schema definitions place in source mean Avro, just like in Java, right? You have the source mean Java for your Java when you're working with Java, right? The namespace is, well, the extension of the file is .avsc, okay? And then the namespace, like as I mentioned before, just a Java package name you will import. So this part is pretty standard. And don't feel like you have to understand everything yet about Avro. If you have some time and you want to understand more, you just go to avro.apache.org. There's a documentation, there's a developer documentation, as well as other stuff, but you can look at the details and you'll find a lot more information. avro.apache.org, because Avro is an open source Apache project. Okay. And here's another example of an array, right? And again, you see that it's a record type, the name is salesperson, and then you have the like name type string, then you have doc attribute, then you have account list, and then you now have the type says I'm an array, and then it just breaks it down, name, account, then you have a record within that. And then just, so you could get more complex, right? This can get more complex, and you just have, I don't expect you to see it all very clearly right now. But if you start to play with this, I would suggest that you create something as simple as this to begin with, like what we have in the course. You do something simple to begin with, and then you expand on more complicated format, more complex. This one's showing you a map. And a map is pretty interesting as well. So remember, there's an assumption. All keys in the maps are strings. So you can only define the value type here when you look at this example. Everything here is sort of standard like we saw before. Then I say map, and then I just define the value because I know the key is going to be a string, right? And this may not be that apparent. Actually, sometimes I always laugh at the developers, the course developers, when we throw these kinds of examples without like a clear, it's just, okay, yeah, look at this. Here's another one for enum. There's some details that you need to be careful with. If you use enum, make sure you're using it for something that you do not intend to change in the future. For example, in this example, when I'm working with cards, these are not going to change literally with the cards. So spades, hearts, diamonds, and clubs, right? Because cards, those are standard for the suite of cards, right? And so I don't expect that to change. So if I use an enum there, it's not a big deal. But like I said, you will come to some of these in the documentation and you'll get more detail. The logical format and stuff here, I'm not really, again, some of these require a little bit of experience working with, but just know that we give you some notes related to this. Like when I said the decimal logical type is an arbitrary precision signed decimal number, right? And then that precision says adjacent integer representing the maximum number of digits and times 10. So there's some things here you have to look at the documentation for. Unless you're using it, it may not make that much sense. But remember, the important thing to know is to be careful when you try to use, if you're working with currency and you're working with money, currency money those kinds of things. There's some best practice. I'll leave that to just say that look at the documentation and try to understand how you want to represent those kinds of things. We don't include that here, but just know that there's a lot of information that you could, I mean, this Avro is a topic by itself. You could spend a lot more time on Avro, but that's not the goal of this course. Now, some very important thing in Avro, you want to understand the concept of a default value. Super important and not difficult to understand, right? You want to definitely understand what that means, right? So I could create a schema and I can say, okay, what value do I want to have if it doesn't, to give it a default value. Default value is so important when we talk about backwards and forward compatibility, right? So if you have, for example, in this particular example, I have this suite type, the name suite type. It's not student record, but suite type, right? And when I'm looking for this, if I have this where, I'm supposed, it's a type enum and then it's suite right here. This is the suite that I'm looking for. It's spades, hearts, diamonds, and clubs. If it's missing, it can assume a default value of spades if it doesn't have if it doesn't have the value, it can make an assumption a default value. So the default values are very important where you can just, if I'm supposed to read name, age, and salary, and I see name and age, but no salary, if I have a default value set, I can just assume whatever the default value for salary is. I mean, that's not a perfect example, but and you also need to know that if you want to accept null, right? When I do this, that means I can either be an integer or I could be null. So you want to be, it's a very important thing. So the value of this field, experience, name is experience. So remember, if you were in a database, it would be like you have experience and then type, right? You have experience. And then what type is it? What is the type associated with it? So it says it can be an integer, but if it's not an integer, it can be, if it's, or null, I'm saying this can be either integer or it can be a null, right? So the value of the experience can be undefined, that's the null, or it can be an integer. So it's very important to know that you can do this, or it's very important to know that you can assume a default value. It's very important. So when you define your schemas, you want to understand that. And then, so Avro, here's the gist for Avro. In Avro, I can have a simple schema, or I can have a complex schema. If I'm going to have a complex schema, I want to use the record type. The record type allows me to do just like a struct in C programming language. I can define my own more complex type using other simple like int, arrays, map, simple or complex types. So in Avro, you could do that. Now, protobufs, we don't include a lot of information in protobufs, but protobuf is very, very important. Google and I think Twitter was involved in this initial project, and protocol buffers are amazing. And they weren't always supported in Kafka. And I think, I forget the exact release in Confluent Platform 5. Maybe it's, I don't know exactly, but it was an early release where we started to support protobufs. And protobufs makes it very simple to define your schema, right? Very, very simple. I mean, if you were playing with other code, you could use the Proto-C compiler to build and do things, but it's really easy to define your schema. So if you look at this, right? Right here, actually it's right here. It was, as a 5.5. So addition to Avro as a Confluent schema addressing now supports protobuf and JSON schema. Okay, right there. I thought it was a little bit earlier than 5.5 actually that we have protobufs. But I know that it wasn't always supported, and JSON was not always supported as well. But when you define your protobuf schema, if you look at this, you see here, it's easy to specify this. I'm using Proto 3, and then the package name, which is very simple, just like we saw Kafka. But then here's where you define, just like we saw message position value before, but yeah, we give it a name. And then in protobuf, it's very simple. I put the type and the name. So the type double, latitude, and then these are tags that you just add on to it. And if I have more, like double, XYZ, then I'll just give it another tag here. If I have another one, ABC, whatever it is, I give it another tag. And you keep on increasing. And it's very easy to use it this way to define my schema with protobuf. I was so pleasantly surprised when I first started playing around with protobuf to see. But unfortunately, my role right now is an instructor, so I don't have to use it for anything else other than the projects revolving around this course. But it's very easy to use. There's some really great documentation and actually some very simple videos on Udemy. If you guys are ever interested, if you go to Udemy, they have some great course for maybe $9, like $9.99, something like this. You can see all protobus, stuff like gRPC. Really, really great stuff. Take less than maybe 10 hours total time. And really, really great stuff. Will bring you up to speed with everything. Really easy to define, use protobuf. Is very efficient. The format of how it stores the data, very, very efficient, right? And the encoding, it works. It just does a great job of it. We don't give you any added information here. We're just saying, hey, look, here's an example of what it looks like. But it's very easy to define your schemas in protobufs. And this is an example of JSON. JSON schema, again, just JSON, very simple, type, and then you have so just like we saw before, give it a name, and then using key value pairs. Latitude is a type, longitude. And so JSON schema is actually very simple. And then we get now to Confluent Schema Registry to talk more about this concept. So, okay, we talked a little bit about schema. Schema is our description of the data. We know that. And we say, look, in Confluent platform, we can use Arrow, we can use protobufs, we can use JSON schema, and okay, that's all great. But we also mentioned the fact, that if you put the schema with your data, it's like taking a suitcase around with you, okay? That's what Arrow will do and other frameworks will do. So you say, well, that's great, it does the job, but it's not very efficient. Think about walking through the streets with every other citizen carrying a suitcase, right? You're not going to move as fast as you're supposed to. So there's more load on your network. And that's true for Kafka. So what does Confluent do? Confluent say, wait a second. We're going to give you this ability to use kind of like a name service. We call it a schema registry. It's not a real name service, but I'll just give you this example. What you'll do is when you have your data, you'll basically go to the name service. It's like taking your suitcase and say, hey, there's my suitcase. I want to leave it with you. And then the schema registry will say, okay, no problem. Here's your little tag. Give me back a little tag that I can put back in my pocket, like a valet. And then it will store that schema. That schema would then be stored into Kafka, right? So then the schema is then stored into Kafka. Okay, the schema is stored into Kafka here. And then when a consumer comes to get this, we'll see this in more detail. But when the consumer comes, the consumer sees your data here, and it sees this byte right there. And it'll say, hey, here's the tag, but again, I'm just telling your story now, but we'll get to more detail. Then it'll take this tag and like go into the valet and say, hey, here's the tag, give me my suitcase. But then you'll again get the schema for this data, and then the consumer will be able to deserialize the data. But we'll see exactly how this works, a better picture coming up. So the schema registry gives you this central management of schemas. Whenever someone says centralized management, that's like a name service, right? Think of like anything you do a lookup. Whenever you're doing a lookup, you have a service providing that. That's like a name service, but it's a centralized management of schemas. And it's like version control because you don't replace one version. You just store different version, like you have version 1 and version 2. So it keeps different version of the schemas in the schema registry. It gives you this RESTful interface, right? So in other words, I could use curl to access it because I have a RESTful interface. And anything that I can use, you can use some other tools that like Postman or whatever you want to use that can go over and communicate with the REST API. So you could do that. It checks the schemas and throws an exception. You can have restrictions just like in the database will. Say, look, if this producer does not conform to this schema, throw an exception, force it. And this is a better way to do things in production. Make sure everybody adheres to a certain schema, so that way you produce the data just like you do in a database workflow. And it allows evolution of the schema according to, so we'll talk about evolution schema, like backward, forward compatibility and stuff like that. We'll talk about that coming up. And remember, when you send the message, the schema with the message, that's inefficient. That's like taking your suitcase around the city with you, right? It's inefficient. So what we want to do is give that ID. We get an ID from the schema registry. That's like getting a little tag from the valet, right? And then you leave your suitcase. But then that ID will be used together. We'll look at that coming up in just a second. So the schema registry stores schema information in a specific Kafka topic. Remember, Kafka topic means it's going to live under brokers. There's a special topic in Kafka, right? And that's the __ consumer offset. Well, this one's _schema, sorry. We're not talking about offsets. So the schema registry is accessible through the REST API and the Java API, and there's also command line tools. So if you want to write code, you can use the command line tool like Avro console producer, Avro console consumer. Then we have one for protobuf and one for JSON, producer and consumer for each one. So you can get to play around with everything before you write your code, right? The schema registry, remember, is part of the Confluent open source community edition, right? So you don't have to pay for enterprise services to get that. And this is important. And with the special, remember the schema, the name of the topic where the schemas will be stored is the _schemas, right? And all of these properties are configurable. But here's the picture that sort of describes what I was talking about before. And I'll go to this picture right now. So you're a producer. We talked about producers before. You want to produce data to Kafka, right? You're going to create your schema here. Once you use the schema registry URL, you will come and register your schema with the schema registry. The schema registry will take your schema, right? And your schema is going to be stored in Kafka. Then what it does is sends you back an ID. And then the ID is what your data, so your data will look, let's just do a simple picture. Here's your data. And yes, yeah, I now have an ID. Okay. And this is what's going to be stored in Kafka. So your data, and then just the ID, just a byte up here, just like the number 7 or something like that, just an ID. Okay. So when the consumers come, consumers will look at this ID, get that ID, let's say it's the number 7, and then go to the schema registry, say, hey, give me the schema for this ID 7. Schema registry will grab the appropriate schema and send that to the consumer. So the consumer can then go ahead and be able to do its job, right? But nope, you don't have to write any of this as a developer. There's a question in chat where Gang asked, does the developer have to? Nope, it's like magic. All you do is specify that you're using Avro serializer, and then you'll be able to just specify the URL to the schema registry. And as long as you define the schema, and we'll see how you define the schema, the important thing is that we built the schema using our JSON notation. Let's say if it's Avro, we built the schema, and if we're using specific records, then we specify the class file that we want to use. Then it could be any type that we build our own type. And then in our code, we just point it to the schema registry. The schema registry handles all of that. The only part you have to do in your code is determine whether you're using specific record or generic record, and you have to create the schema. And to create the schema, you have to understand your data. What does my data look like, right? I need to know the different fields in this data. And this is where all of you guys are developers or who your data modeler, whosoever is, you guys sit there and decide ahead of time and then build a schema for whatever user data or bank data, whatever it is, whatever the data format you need. And then once you register that schema, then all enforce the rules so that all developers, writing producers, have to use a certain schema when they're writing to a certain topic. If you're writing to topic A, you need to use the schema. If you're writing topic B. But if you do that, then developers will not be able to, you don't want people to just send any schema in production. In production environment, you want to have some rules. But when the producer first goes ahead and produces the schema, they will cache. There's a local cache. So for future records, they can use the same schema, right? And then same thing with consumers first get that ID. Consumers will try to cache it as well. So the consumer will look into the local cache to see if hey, do I already have this? And if it doesn't have it, then it goes through the lookup process talking to the schema registry. If it already has the schema, right, then it just goes ahead and uses it. So it caches the information, caches what it needs, right? And if it doesn't have it, then it does the lookup. And this is important. Now in the schema registry, this communication is only on the first message of a new schema. So only on the first message of a new schema, then the producers and consumers will cache the schema ID for all future messages. So the first time it sees a new schema, that's when it needs to communicate because, hey, I don't know this. So I'm going to communicate with the schema registry to find out what the schema is. And then I'm going to cache it. So if I ever see a record that looks like this again, I'm going to use it. Okay? And this is the thing. So just an overall view of the schema. And then integration with the schema registry, let's say Java clients, KCCode, all of these different services that we have in Kafka integrates with the schema registry. All of these services work with schema registry. That's the key thing to know. Very important, right? So I don't need to spend any more time on that one. And then here, the schema registry REST API allows you to do a lot of great stuff. If you've never used curl before, I highly recommend that you spend some time to get used to it. But of course, there are other tools out there that you can use that allows you to communicate with the REST API. So, but curl, just go to Google and just do a curl manual. It's probably about 1.5 megabyte size, somewhere there. Last time I looked, it was about that. But you can download that. But yes, you're just using curl to register a schema for keys, right? So notice I'm specifying the version and then the data schema, key value, pair JSON notation, and I just put the URL. Remember, this is the name of the schema registry container or system, and then specify. Notice I'm registering on the subjects. I have a topic name -key, and then version. So we don't talk a lot about the different naming strategies in this chapter, but it's important to know. We'll see a little bit about it. And then notice you get back an ID of 1, right? After you register the schema, you get an ID 1. Yeah, I can register another schema. And this is just showing you how you can manually do this. In your code, you won't be doing curl, of course, right? We'll look at your code coming up in just a second. No, the ID is not something that you define. The ID, think of it as like the schema register exists and is going to give you this number. Just when you register, hey, I'm going to give you this number and you get whatever digit I gave you. Yeah. So you don't have to worry about generating it. And this is just showing you a manual approach to say, look, if you want to play around with it to see how you can manually register schema using a command line tool like curl, or you could use some other tool that talks to the REST API. But this is how you can manually register the schema. And it will show you that if I come and register another schema, notice I get another ID. And then on the next page, you'll see that now this is, hey, I can retrieve the schema. If I go and say, okay, I want to go look. Remember, this schema registry will always exist in your enterprise. You do not run the schema registry on your broker. So if this is my Kafka cluster, and let's say I have these 4 brokers, brokers 1, broker 2, broker 3, broker 4. I would also have, let's say, 1 or 2 instances of systems up here that these are my schema registry servers. And in production environment, I want to run more than one for redundancy, right? And you'll see some architecture towards the end of the course. But this needs to have a URL. This is like a container or VM or physical machine, whatever you want to call it. But I need to be able to, that's the name for it, right? It's just like a host name. You must have a way to connect and then a URL to get there. Okay. And so if I do a retrieve the schema, I can do a curl -x to get and then specify the schema, give me the schema with this ID of 1. And then you see that it shows you the schema here. And this one says check all the different schema subjects stored in the schema registry. And when I say this, look subject, and it just shows me here I have the topic name, key, and topic name value. So we'll see a little bit more about the concept of subject coming up in just a second. Okay. And then schema evolution now, this one, very important concept. And it says schemas may evolve as updates to the code happen, right? So schema registry enforces what's called the subject compatibility setting when a new schema version is registered. The versions can be backward, forward, or fully compatible. So this is what we need to talk about now. So set the subject schema compatibility based upon the anticipated evolution. The default is to have backward compatible. So what does it mean by backward? So let's say I write the data today and I have these fields, field 1, field 2, field 3. It has the date of birth, it has name, and it has facts. And maybe in the future, I want to have the data format change, field 1, field 2, maybe field 3, maybe field 4. Maybe I have the date of birth, name, and then facts, but I want to email because maybe my application will be using email now. No one uses fax anymore. So if I wrote an application, if I write an application using a schema today, this is a new app using this schema. That means my application, or in this case, we'll say my consumer, knows about this field 1, field 2, field 3, field 4. Then what if it comes across the data that has only name and facts? What is it going to do? If I want the new application to be able to read the data that was produced with the old schema, that would be backward compatibility, where the new consumer can, you're running with the new schema, but you can read data that was produced with the old schema. That's backward compatibility. To be able to do that, I need to be able to assume some default values, right? To be able to say, look, I don't see email, but I will be able to accept a default value for email or whatever it is, or to be able to ignore. You got to be able to assume a value, or you got to be able to ignore a field, right? So we want the new applications to read the old data, and we want the consumers that are written with the old schema to be able to read the data that was created with the new schema. So this is what we want. And when I said, if I don't want any of that, then I can set it to none. And then in this case, right, it disables compatibility checking. But in your production environment, you want to make sure that you have a schema rules. Like I shoot for full compatibility, but some people will say, well, if you have full compatibility, there's some issues to consider, but I'll take those issues, but I will still shoot for full compatibility because maintaining code in your infrastructure is one of the most difficult thing to understand. Is removing field 3 backward compatible? Actually, hold that thought for a second because we have some really good examples I'll show you. And it's the same, pretty much the same thing that I'll show you just a second, gang. So we're almost there. We'll see like a backward, forward example. But here's the first description of it. So you see here, backward compatible. It says, look, consumers using a new schema can read the data produced with previous schema. That's what backwards. For forward compatible, consumers using the previous, that means the old schema, can read the data produced with the new schema. So you can read the new data. And then full compatibility is what I say people should shoot for. Combination of backward and forward. And then none, we just looked at none. So you can also have that as well. But remember, you want to shoot for full compatibility. The default is backward compatible. Backward is the default. So if you look at this, there's also this concept of backward transitive, right? And transitive, just like in security world, like if I trust you and you trust Joe, then I trust Joe. So it's transitive trust because I trust you, you trust Joe, so I trust Joe. But in this case, when you say backward transitive, say consumers using a new schema can read data produced with all the previous schema. So that's why it's transitive extends to all the previous schema. And if it's forward transitive, it's just the opposite. The consumers using the previous schema can read data produced, again, data produced with all the new schema. So in other words, all the new versions, everything. So that's what the transitive here refers to. Oops, excuse me, just for a second. Okay, so with this in mind, let's go on to this one now. So here's an example of the schema now. And this is what I was referring to, gang, when I said that we are going to see an example of this coming up. So look at this picture. So let's say you have we're going to produce data, and this is the version 1 of the schema we're using. Our data is going to have a field, first name, that is a string, last name, that is a string, and then age. And the age is supposed to be int, but there's a default value associated with it, -1. And then the new schema, version 2 of the schema, right? You have just the name, right? Which we also have name here, but name. And then we have age, right? Which we all, but notice there's no last name here. And then there's also hobby here. There's no hobby on this side, but hobby is here. And there's default value. No, nothing there, right? But it does have the default. So the producer, so in this example, the producer writes message with schema V1 with those fields. And then on the other side, the consumer is using V2, and the consumer expects to read the fields last name, age, and hobby. So the consumer will read the first name, last name, and age, right? Because you have the first name, last name, and age. Sorry. So the first, let's just get, there's something here that is not, let me just bring this to this example and explain this to you. I like to just look at this example here. And this example is not really my favorite, but it's okay. So if we look at this one, it says it's backward or forward compatible. It's the same thing we're just looking at, right? So the default value, I have last name, age, and then hobby. So it's a default value for hobby. So the consumer that is using version 2 of the schema, right, can process the messages produced with version 1 of the schema. So that means it's backward compatible. So there's no default value for first name, which means the consumer using V1 cannot process the messages produced with V2. So schema V2 is not forward compatible with V1. Okay, but so V2, again, this is trying to show you just a simple example. So this is, yep, backward compatible. But let's look at another example here. If you look at this, again, same picture we're looking at, it says, what does this look like? And then this one is forward compatible. So if you look at this, the default value for age that you see here, I have first name, last name, and age, and then there's a default value. This one has first name, last name, and hobby. There's no default value here associated with that. So the default value for age allows the consumer using V1, version 1, to process messages produced with version 2. So V2 is forward compatible, right? And then no default value for hobby means that if you're using version 2, you cannot process messages produced with version 1. So schema V2 is not backward compatible with V1. Again, it's just sort of interesting. And then here's the last one here that shows you, if you look at it, same thing we've been looking at, but then you look at it, check marks is checked for both check backward forward. Because why? They say, look, the default value for age allows the consumer that is using version 1 to be able to process messages produced with version 2, right? So V2 is forward compatible. And then because you have a default value for hobby, means that the consumer using version 2 can process message produced with version 1. So V2 is backward compatible. So that's is forward compatible because it's backward and forward. So I can read the name, first name, last name, and I can assume the default for hobby, right? No problem. And in the other side, I read the first name, last name, there's no age. I just assume the default for that as well. So knowing how to set the defaults is very important backwards to be able to set up your schema. Now, some people say, hey, if you do full compatibility, there's some added, so I say shoot for it regardless of what goes on, because you need to have that full compatibility in your code. That's what I would shoot for. But again, you can do your research. The default is backwards in Kafka. Now, when you're dealing with schema, I wish we have more data in this part. We do a really great job in our documentation for this section. But this section of the course is really sparse when it comes to subject name strategies. The default is to have the topic name strategy, where you have the whatever the key is, key subject name strategy, and then actually we will see this coming up in just a second. And then you could also have something called record name strategy or topic record name strategy. So for example, the topic name strategy is the default. So if the topic is driver positions, you see that the subject becomes this driver positions dash key, right? That's what it says. So it's like the topic dash key and then driver positions dash value, right? So this is important. You have the topic dash key and then topic dash value. But if you're using the topic record name strategy, you can have like the topic dash type dash key and then topic dash type dash value. Can be very useful, right? But we don't go into a lot of this here. You can see the topic name strategy, record name strategy. In other words, if I'm putting all my data in one topic, I need to have a better strategy to manage the schema. So I need to be able to look at these. You need to look deeper into this, like the record name strategy or the topic record name strategy, other than the default. And I'm sorry, but we don't give you, our documentation does a really great job in the section that talks about these subject name strategies. And unfortunately, we don't include that here, but just know that it's really great in our documentation. So I will just say that if you are storing records, all your, like a whole bunch of different kinds of data in the same topic, you can do that in Kafka, but you want to look at these naming strategies to understand it a little bit better. Okay? And it's a great read in our documentation. I can tell you this, but I also mentioned that it's well, I did tell you that it's easy to read and very powerful. So now we get to the actual code example, Avro producer example, right? If you look at this example, almost everything is the same as what we saw before. Notice you have your properties object, you have producer config, remember, specify more than one brokers, then configure the serializer classes. Notice I say for key, I'm using string serializer, okay? For the value, I'm using Kafka Avro serializer. This is why I'm specifying that I want to use the Kafka Avro serializer. And then notice that I also specify here that props that put configure the schema registry server. I specify, look, I want to use this. Here's my URL. I'm using the schema registry URL config and specifying the URL to my schema registry. And then here we create the producer, which expects like a position value. Remember, that's from my schema. It's generated from the Avro schema. Remember, we use the schema to generate the class, right? And in Avro, we can then use that class. So we have the object. So the Kafka producer, instead of just using string, I have a string and then a position value. That's what the producer is. And then I pass the properties. And then now, let's say create the key. So I set the key to driver one, and then now the value, remember value is position value, but I can specify now the new position for latitude and longitude, right? And then I create my producer record, and then I just specify, here's the topic, here's the key, here's the value. And then I send my record to Kafka. The magic is in this, it starts here by specifying the serializer, Kafka, and the schema registry. And the fact that because I'm using Kafka, I use my JSON, I create my schema in JSON. And then from that, what do? I go ahead and create the class file. The class from that. Okay. Oops. Sorry, just a second. My screen is going dark. Sorry about that. I have this daylight savings on my clock, on my computer. And around this time, it typically changes the color from bright to dark, so I can start wrapping up, but it's there. So with this in mind, that's the first start. And then here's an Avro consumer example. That was a producer. And this is the one for the consumer. So in the consumer, it looks pretty much very similar in a sense to what we've seen before. But in this one, you'll see that the interaction with the schema registry, everything is part of the Kafka Avro serializer and the deserializer. That's the magic right here. So everything we've seen pretty much looks the same. But then here I say consumer config, yes, my deserializer. This is the Kafka deserializer class, right? And then here's the URL to the schema registry. And then now notice this Kafka Avro deserializer, so the specific Avro reader, and this tells me for the specific records of, and then I set that to true, right? And this is very important. Then the rest is almost exactly like we saw before, right? The consumer would then subscribe to the topic. And then once you just subscribe, you pull, you wait for some duration of time in milliseconds to get your partitions and records. And then once you get your records, you do whatever logic here. This is where you do whatever logic. In this case, we're just printing out the screen. But you see this part, when I said that you don't have to specify anything other than the Avro serializer and the schema registry URL, the magic, a lot of this happens in this Kafka Avro serializer and the Kafka Avro deserializer, right? So hopefully let's go on to, now just one note here that's very important. Notice this line number 7, and we put this note in your documentation, but I want to make sure I point that out right here. This line number 7 right here, right? And I have some notes in my, as I go through the lecture, I make sure I point out important points. Now, they said this is required for the preferred behavior of specific code generation. If this line is omitted, then the default of generic record is used instead, right? So you have to, we're using specific record, we're generating the class file. Position value, yes, Dan, you're right. That's the schema object. In other words, we generated that class file from the JSON object, from the JSON syntax that we wrote. And then this is now that instance of that class. Okay. And then now we look at the REST proxy example. REST proxy example, almost exactly the same, but there's a difference here, big difference, right? You're sending JSON to the REST proxy. You're not sending you're not sending Avro, you're basically sending JSON, and then you're using HTTP, right? But the REST proxy is the one that deals with the Avro. So remember, you're using whatever language you want to use here. You're the producer. You're sending this information here to the REST proxy, right? And a REST proxy is the one that takes care of like whatever you have to do with Avro or whatever types, because it's going to be working to Kafka. At this part, it's just JSON that you're dealing with going to the REST proxy. So this is what the note, you'll see this in your documentation. Only the REST proxy deals with the Avro serialization and deserialization, right? And yeah, so very important note. So everything else is pretty much like what we saw before. You don't have to even know Python. The important thing is know any programming language. Just know that you're specifying, notice here, you know, Kafka Avro in a version, and then you're specifying your schema, JSON notation. This is not just schema. And then when you post and send this to the REST proxy is going to take care of everything for you. And here, this is just saying the consumer example, pretty much very similar. Like I said, you don't have to know Python for this. The important point is you notice that you're dealing with JSON, not Avro, right? All of the serialization for Avro is happening with the REST proxy, not with your code. You're just sending the JSON to the REST proxy. Okay? So your consumer, everything is hidden away. So the producer needs to know about Avro, let's say as it sends the schema with the post to the REST proxy, but it's sending the JSON notation, right? So the producer needs to know, like, yeah, this is Avro here, but here's my schema. Notice it's just schema sending there. That's your Avro schema. And then the consumer needs to be able to know, of course, just some of the same thing. And then the consumer will be able to, but you're sending this to the REST proxy. You're not doing anything else with it. And sorry, guys, it's just about that time. Let me just see. Sorry, my apologies. Let's see where we are here. Oh, we're literally done. My apologies. Let's just wrap this up right now. So this is just the consumer part, and the consumer code is here, right? Do stuff, and it's your lunchtime now. But let's just finish this. This last part just shows you that I can set a schema on the shell, in the shell, and then when I set the schema, I can then use the Kafka Avro console producer and then just use the $my schema. Remember, in shell, if I have a variable assigned value, well, as a variable assigned 5, if I say $var, like echo, I would get the 5, right? So when I say $schema here, I'm saying use the schema here to produce the data to this, or yeah, to produce the data to that topic. So there's a simple example. And this one showing you the consumer, same thing. Use the schema. So the consumer comes and then you specify the URL, and the consumer, of course, will communicate with the schema registry and be able to get the schema from there. So no big deal. But here's another example using protobufs. I create the syntax in protobuf. Then I use it to produce the data to Kafka, right? Using the value of the schema. And then once it's produced to Kafka, then the Kafka protobuf consumer, same thing, needs to just be able to communicate with the schema registry to be able to read from that topic, because it will be able to get the schema. So that's not a big deal at all, very straightforward. And then this JSON schema, same thing. If I want to experiment on the system, I say my schema set to this value, and then I can use the Kafka JSON schema console producer to produce some data to the broker to this topic using the schema that I just set. And then, of course, once the schema is registered with the schema registry, I can come and consume the schema. All I need to know is connect to the schema registry, and I will be able to read the data. So these tools make it very easy for you to test. And of course, the beautiful part here at the end, you could, if you look at the Confluent Control Center, look at the topics. I notice for key, value key, and then I can see the schema right there. And notice I can edit the schema, look at version history, download the schema, and it shows you the format right there. So it's actually pretty nice in the Confluent Control Center. And that brings us to this point. So perfect. I thank you for your patience, but look at the lab that you will be doing. You will be doing this lab and you'll be doing lunch as well. So let me tell you the combined time for your lab and your lunch together for what we need to do. And then you guys will take some time to do that. So thank you for that.